So, uh, so con retaking from where we left off the last video, we said we explained the basic idea of multivariable optimization and why we can't set the functions equal to each other, and why instead we set their gradients, this equation of their gradients. So how can we solve this problem? Now, we said that the gradient of f must be equal to a constant. Well, it could be also a variable. Well, the gradient f must be equal to the Lagrange multiplier times the gradient of our constraint function. Our constraint function is, in this case, x squared plus y squared equals 1. But we don't need the 1 by the moment to set this equality. So we have the gradient of f. We have that f is equal to x squared times y. So its gradient is equal to 2x y, and in the y component it will be just x squared, and we can set it equal to the Lagrange multiplier times the gradient of g, and we said that our constraint function, which is x squared plus y squared, is equal to 1. So for the x component it will be 2x because of this, and the same with the y component, 2y. So now we can set the x component to be equal to the Lagrange multiplier times 2x, and the y component equal to x squared equals the Lagrange multiplier times 2y. So 2xy equals lambda times 2x, and x squared equals lambda times 2y. And we also know that x squared plus y squared equals 1. So here we have three variables and three equations. So this has a solution. Now, how can we get the points? Well, let's start with the first equation. We can cancel out the 2 and the x, and we get that y is equal to lambda. That's what I meant by that lambda could be either a constant or a variable itself. And x squared equals lambda times 2y. So according to this, we can set x squared equals lambda, but lambda is y, so we have y times 2y. So we can simplify this as 2y squared. And now we can plug in this equality here. Now, so we have 2y squared plus y squared equals 1. So 3y squared equals 1. Y squared equals 1 over 3. and y is equal plus minus a square root of 3 over 3. Now let's solve for x. We have this equality, so whatever value we plug in this equation for y, the negative sign will cancel. We are gonna be left with a positive sign, so that doesn't matter, and we can set x squared equals 2y squared, but y squared is 1 over 3, and so that means x is equal plus minus 2 square root of 3, or we can simplify it as square root of 6 over 3. And now we just got the next point. Square root of, we have a square root of 6 over 3, comma, a square root of 3 over 3, comma, minus square root of 6 over 3, comma, square root of 3 over 3, comma, square root 6 over 3, comma, negative minus square root of 3 over 3, comma, square root of 6, minus square root of 6 over 3, comma, square root of 3 over 3, minus. And these are all our points, but not but if we plug by one by one each point, we will notice that just some points actually maximizes and others do not maximizes the function. But we can plug in